worth spending time on those. So let's start here. What are we going to do on number 2 to start with? Yeah, having multiple choice is not helpful at all in these problems. You got to be able to integrate it with or without the multiple choice. So what am I going to do on number 2? Ooh, you must have been cut out. You still there? Doesn't sound like it. John, you went offline. Hi, John. Yeah, I saw that it said on my end you went offline. Go ahead and reboot it and log back in with the same meeting ID number. Hello? Oh. Yeah, hi, John. That's okay. Yeah, we appear to have phone problems. What are you on Comcast by chance? Okay, because I've been having problems with my Comcast the last few days. But anyway, go ahead and reboot your computer, do whatever you need, and log back into that with that same meeting ID number. I'll just leave it up. Okay? And I'll just wait for you to get into the session, and then we'll tackle these problems. Okay. Bye-bye. Mm-hmm. There we go. You there?
Yeah.
Okay. Yeah, I used to have CenturyLink, and I think they were a little worse than Comcast. So
Yeah, they seem to cut out.
I switched to Comcast. But anyway, let's see if we can get going on this problem here.
Okay.
What's the first thing I'm going to do on number 2? Very first thing.
Should we set up what u is equal to?
No, it's not a U substitution problem. I know that it looks like it could be because the derivative of the inside looks like it would be minus 2x, but it isn't.
Right.
You have this square root of x also.
Right.
So the first thing you want to do when you see a radical sign is convert it to a fractional exponent.
Okay.
Always. Radical sign, well, at least if it's radical of x. Okay? In other words, I'm going to change that to this.
Okay.
Now what can I do?
You can distribute.
Yeah, and now it becomes now it's going to be easy. In other words, now it's just a power rule problem.
Right.
So what's the next step?
Increase each power by 1 and then divide by that.
Okay, so that becomes x to the 5 halves divided by 5 halves, which is the same as multiplying by 2/5, which makes a 2 right there.
Right.
Over here, it's going to be x to the 4. I'll leave the 5 there, put the 4 under there.
Right.
Should see an answer that looks like that.
C.
Okay. These are the kind of problems that I think you should focus on.
Okay.
Not that we should ignore the other ones, but these are definitely going to be easy problems for a Calc BC exam.
Right.
You gotta know how to be able to do these. Always.
Right.
Okay. If you can't do a integral of a logistics function, well, that's a different story. So what? You'll lose a point. But you're going to have lots of these kind of problems.
Okay.
19. What kind of technique do we have to do to integrate that?
Separate the fraction.
It's integration by partial fractions.
Right.
So let's start with that fraction. What do I have to do to solve this?
Make it a over 2x minus 3 plus b over x plus 2.
Okay, now what?
And then it would be 7x equals a times x plus 2 plus b times 2x minus 3.
Okay. Now what?
Plug in -2.
Okay.
So
that gives you -14 there.
Right.
0 plus b times what?
B times positive 10 or negative 10.
-2, plug in -2 for x.
-2 times 2 is -4. Oh, positive 7 or -7. Sorry.
-7. Okay. So therefore, b is equal to 2. Right?
Right.
Now let's solve for a.
So then, I don't know what to plug in for that.
Well, we want to make that equal 0, correct?
Yeah.
So set it.
3 halves. Plug in 3 halves, I guess.
Yeah. In other words, when x is 3 halves, so we're going to have 7 times 3 halves equals a times 3 halves plus 4 halves is 7 halves. Now I'm going to multiply both sides by 2. And I got 21 equals 7a, a equals 3. So I can go back up and substitute what I've calculated for a and b. A is 3, b is 2. Now, in case you were expecting an x, you don't necessarily have an x in the numerator.
Okay.
Okay, just because we have an x over here in the numerator, it doesn't require either of these numerators to have an x. And
Right.
if you want to verify it, well, the right side is 3 times x plus 2 plus 2 times 2x minus 3. I distribute, I get 3x plus 6 plus 4x minus 6. 6's cancel, and I got my 7x.
Right.
Now,
Okay.
once you get it into this format, it becomes, well, let's do it. What's the next step? In other words, now we're going to take the integral of that. So that's going to be the integral of that plus the integral of that. So let's
Right.
to these integrals on the right side. What's the first one?
Plus, the first one would, well, we should pull the 3 halves out.
Well, you can't pull 3 halves out.
Why not?
Well, because first of all, I cannot separate this into 3 over 2x minus 3 over 3. I got two terms in the denominator. So I cannot factor out a 3 halves there easily.
So I could pull out a 3.
You can definitely pull out a 3.
So that would make it the integral, 3 times the integral of 1 over 2x minus 3.
Now the question is, what is that?
The integral of that would be 3 ln absolute value of 2x minus 3.
Well, notice what the problem is. If you go to differentiate, let's leave that 3 out of there for the moment, just not to make it more complicated. If you differentiate this, you get what? You get 1 over 2x minus 3, but then you got to take times the derivative of the inside, so you actually get that.
Right.
So the integral of 1 over 2x minus 3 is not natural log of this. It's natural log of that divided by 2, divided by the derivative of the inside.
Okay.
Okay. Now, the reason it's not usually an issue that hasn't come up before is because everything we have done has been stuff like this. Now, that is the natural log of x minus 4. Because notice what the derivative of the inside is. It's 1.
Right.
So as long as the derivative of the inside is 1, you don't need to worry about it. But if I had this, now I've got to divide this whole thing by 2.
Okay.
The derivative of the inside is 2. And notice that I'm now going to take the derivative of, well, here, there's a 2 there. So I take the derivative of that, which is 1 over 2x minus 4 times 2, which takes care of that 2.
Okay.
So let me just be more general here. There's a general rule here that can be applied in at least 3 instances. Here's one of them. What's the integral of that?
The integral of that would be 1/5 cosine 5x.
Yeah, the way I do it, I mean, I don't care how you do it, but you got it right. It's first of all, I'm going to take the antiderivative of sine, which is minus cosine
Right.
of 5x. But then I'm going to divide that by the derivative of that inside, 5.
Okay.
That's where you got your 1/5. Okay?
Right.
So in this instance, I'm always dividing by that constant. Also, if I have this one, what's that equal to?
E to 3x over 3.
Divided by the derivative of the inside. Same with natural log. Now, that's assuming that the derivative of the inside is a constant.
Right.
In other words, something like this just becomes 1 over 3x minus 5 times the derivative of the inside. Now, if the derivative of the inside is that, then those integration problems become a lot harder. But
Okay.
I don't think you'll see any. That's probably of an order of, it's like the homogeneous solution for differential equations. I don't think you even get taught that, do you?
No.
It's in the book, but there's only 2 techniques in the book, and one is separation of variables and the other is the homogeneous. And I've never had a student in 10 years that had to do one by the homogeneous technique.
Yeah, I don't think we get taught
That's
that.
a good thing, too, because it's hard. Okay. Okay, so again, what is our answer going to be here?
3 ln 2x minus 3 over 2.
Is that 2 inside the absolute value markers, or is it outside?
Outside.
Yes, which means I can put it under that 3. In other words, it's not the natural log of that divided by 2.
Right.
Okay, what's the right side?
2 ln x plus 3.
X plus 2, I think.
Yeah, I read it wrong.
X plus 2. And the derivative of the inside is 1, so you don't need to worry about the chain rule there.
Right.
Plus C. So when we have, yeah, it looks like A, doesn't it?
Yep.
Okay. Let's go to the next page. This is weird how they went 119. Oh no, it didn't even go 1. It went 219, and now this is going 2 number 78.
Yeah, it's a weird packet.
Gathered together a lot of problems and patched them together.
Yeah.
Okay, what are we going to use for 2?
Integration by parts. Or wait.
That's not a bad guess, incidentally.
Yeah, but then there is an x in the
Because
exponent.
you have a polynomial times an exponential. It's just
Right.
not the easiest way to do it. You could probably do integration by parts. I don't know.
Right, but it would take.
What pattern are we seeing?
Well, the exponent is the derivative of the exponent is in the equation in front of you.
The same degree as that x.
Right.
In other words, if I was going to use u substitution, what would u be?
X squared.
Okay. Do the rest of it. What's du?
Du is 2x, or 2x dx.
Okay. And now we can do it either way. You tell me how to proceed from here. Turn this into an integral of u. Remember, there's 2 different ways. I actually probably prefer doing the other 2 steps. In other words, solving it for dx. I think it's more understandable that way.
Probably.
Also does not require you to do this out of the box move where we put a 2 in front of there and put a 1/2 out in front of the integral sign.
Okay.
Let me just show you. Let's do it my way. And I don't know. I got to believe anybody's going to think this is easier, and it's only one more step.
Right.
And so I solved for dx. Now let's write this integral as an integral of u. What do I have?
1/2 the integral of
Hold
e
on,
to the
let's not take anything out of the integral sign yet. Let's start with the first term, x. There's an x there.
so x
E to the x squared, what am I going to write?
e to the u
Okay. And now instead of dx, what am I going to write?
du over 2x.
And now we've accomplished the most important thing, which is to get rid of that.
Right.
Now you can take that 1/2 out. It's not really neat. I guess it's helpful. But the rest of it is a piece of cake. In other words, this is 1/2 e to the u plus c. And in place of e to the u, I'm going to put e to the x squared. And that answer should be one of those answers. A, again. What's the difference between A and D? A and D, oh, that's a minus C, I'll bet. No, what is the difference between A and D?
D is e to the 2x.
Oh, you're right. I just noticed it. Yeah.
Yeah, I was confused for a second there too.
That's funny. Yesterday I was teaching an ACT seminar, and the one statement I made was that you will never ever in your life see 2 correct answers on a math question if it's multiple choice. And here I thought I was, well, I did add, unless it's a typo. And here we came across a problem, and I looked at that, and boy, that looked identical to that.
Right.
So you got to be careful. All right. So let's have a look at 78 and see how hard this is. Can't be that hard. It's hard looking, but sometimes these actually aren't that hard. Because when you immediately see this problem, what's the most important thing you want to know? What does integral mean?
Integral means area under the curve.
Okay, and we're not even looking at curved lines. We're looking at a graph of all straight lines, which means we don't need calculus to calculate the area under that curve. We can do it with geometry. So let's do it with geometry. We don't even need this over here. That's immaterial. Hold on, let me turn my thing on. At least I think. Yeah, and that's why they don't give us the function. In other words, we don't know how to integrate that because they don't tell us what f of x is.
Right.
Doesn't matter what f of x is. We want to know the area under the curve from that point to that point.
Or no, from -1 to 9.
Oh, excuse me. Thank you. From this point. Okay? How are we going to do that?
I would probably just count the squares.
Well, yeah, I'm going to break it up. Okay, count the squares. What's the area from -1 to 2?
-3.5.
Well, from -1 to 2, it's -3.
Oh, yeah. Well,
from 2 to 3, it's -1/2.
Right.
And then starting from there to there, what is it? Whoops, go ahead.
From 3 to 9.
No, let's go from 3 to 5 first. You know what? We could go from 3 to 9. I didn't realize that's the base. We know the height. We'll take 1/2 base times height. So when we go from 3 to 9, the base is 6. Height is 2. What's the area of this?
6.
Plus 6. So what's the net area?
The net area would be 2.5.
which isn't on there.
Right. So I think that we have to plug in 3 times 2.5 plus 2.
Ah, you're right. You're right. We did have to pay attention to this because the area of just this is going to be 3 times 2.5, right?
Right.
So the area of just 3 times the function is 7.5. And what's that going to do?
I'm not sure.
Conceptually, think about it. If I'm going to, that's a vertical shift, right?
Oh, yeah.
Okay, so if I'm going to vertically shift this whole thing up 2 units, it's going to look like this. And what's that going to do to all my areas?
It's going to be all positive.
Yeah, this will come out to be plus 3.5. This one has another 2 units on its height. So it's now 6. Hold on a second. Did I do that right? I'm not sure I did do it right. We go back and we go from -1 to 2.
Mm-hmm.
That's a 0 area. Correct?
Yeah.
Okay, so that part's 0. And then this part right here is 1 by 1. That's positive 1/2. No? Plus the 1 below it. So that's positive 3/2. Is it not? In other words, if I'm shifting everything up by 2, then what I'm looking at is it's just 1/2.
Right.
Now I'm going from here to there. It has a base of 6. It has a height of 4. So that has an area of 12. Darn, that answer isn't on there either.
I'm thinking maybe that if we treat f of x as like a variable and
I like your thinking there.
we integrate like
You got it. I think this is what you're saying. Right?
right, and then just integrate that and then substitute in 2.5 for f of x.
Okay, so this part is 7.5. This becomes 2x. And if you evaluate 2x from -9 to there, you get 18 minus a -2, which is 20. And bingo! We found the answer.
Right.
Who says multiple choice doesn't help? Yes, I think you did it right. I think the mistake I was making was considering this a function shifted up by 2. And for some reason, I don't think you can do that. I think you have to do it this way here. And then, of course, you can take that 3 out. Now everything becomes relatively straightforward.
Right.
Okay. Before I let you go, let's just take a look at this third page and see if I need to ask any questions about it. Let's see. Did we? I covered all problems. Yeah, we covered everything on those 2. Okay, so this one here. Okay, number 86 is one of the first ones we had in the very first session we had.
Yeah, that we spent
I couldn't do it then. I'm not sure I can do it now, but I might be able to. I'll take a look at it. Maybe I can do it and figure it out by Wednesday.
Okay. Okay.
But before you go, let's take a quick look at 27.
Would that just be substitution?
Well, they're not asking us to integrate that thing. They're telling us the integral of some formula is this. So how would I get f of x? If the integral is equal to this, then the derivative of this gives me f of t, correct?
Right.
And then I can integrate f of t from 1 to infinity and see what I get. But here's what I'm saying. In other words, if this is true, excuse me, I won't solve it, but I'll just start it. If that is true, then the derivative of the right side of that equation has to be f of t.
Right.
So we're going to differentiate this. That'll give us f of t, and we can switch the variable back to t.
I have a question.
Uh-huh.
So with the integral from 1 to x, wouldn't that just make it the integral of f of x dx because of the fundamental theorem of calculus? And then
absolutely, no matter what that lower number is, whether it's 1 or 10. If you're going to x, then the integral of f of t is f of x.
So then
no, not really. What the fundamental theorem of calculus says is if you take the derivative of that.
Okay.
In other words, if I do this, it's equal to f of x.
Okay.
But we're not taking the derivative of it.
Okay.
So I'm not sure the fundamental theorem of calculus actually comes into play here. I think what we have to do is take the derivative of this. By definition, the derivative of what I've circled should be equal to f of t.
Right.
We'll just substitute whatever we get. We'll substitute t for x. And then we'll take that function and we'll see if we can integrate it and see what happens.
Okay.
My guess is it's going to be divergent, but it's purely a guess. Without doing the math, I really wouldn't have any idea.
Okay, I'll work on this one.
This is easy enough to differentiate. Well, I'm not sure it's easy, but you should be able to do it with those 4 rules, the 4 differentiation rules.
Right.
So you'll come up with a function that's the derivative of the amount, the function circled on the left, and then we just have to integrate that function. Now, I thought I might be able to do a shortcut here by substituting infinity for x, but that actually comes up with 10 as an answer. Because if you take the square root of 4x squared, you got 2x, so I basically have 20x over 2x, which is 10. But that's not the way to do it. I was misthinking about it that way. We can start here at our next session. And then maybe by then I will have figured out how to figure that out. And we can go from there. And if you have new stuff, by all means, send it.
Yeah, and I'll send it early.
Okay. Sounds good, John.
Thank you.
Have a good rest of your day. Bye-bye.
You as well.